The world around us is a fascinating place, and it is not confined to our planet. What we see around is just a tiny part of the entire cosmos. And to date, terrestrial spacecraft have been able to reach only as far as the limits of the solar system. I invite you to set out on a journey which will start with the Voyagers' trajectories, continue around the closest stars, and end in the infinite depths of our universe. Our trip is going to be swift, absorbing, and really enthralling. Please make yourselves comfortable, and let's begin. Kosmo, the first in outer space. During this long time span, the Voyagers have taken detailed photographs of Jupiter and Saturn, as well as their satellites. Uranus was closely studied, and its 11 moons were discovered thanks to the Voyager mission. It's the pictures taken by Voyager 2 that allowed scientists to be able to see one of the most controversial bodies in the solar system, Miranda, Uranus's satellite. The subject of big space travel was first broached in 1966. Gary Flandreau, still a student, published a scientific paper where he predicted the orbits of Jupiter, Saturn, Uranus and Neptune getting closer together by the late 1970s. The predictions proved to be accurate. On the 10th of March 1982, a full planetary parade took place. The 8 planets of the Solar System and Pluto were on the same side of the Sun at the angle of 95 degrees. The rendezvous of the giant planets provided opportunities for using gravitational maneuvering to fly the two apparatuses on the trajectories Jupiter, Saturn, Pluto and Jupiter, Uranus, Neptune. 10,000 possible trajectories were considered when the program was being worked out before the two of them were finally agreed upon. Apart from exploring furthermost objects of the solar system, the Voyagers have taken a great number of photos of our own planet, including one of the most well-known ones from a record distance of almost 6 billion kilometers. The idea of the picture, as well as its name, the pale blue dot, belongs to a prominent astrophysicist of the 20th century and an outstanding popularizer of science, Carl Sagan. The scientists didn't rule out the possibility of the Voyagers encountering extraterrestrial beings. That is why both spacecraft carried a gold-plated audio-visual disc with greetings in 55 different languages, significant scientific data, views of the Earth and its position in relation to its 14 pulses. Music holds a special place in the message to intelligent aliens. The collection of music includes classical works by Bach, Mozart, Beethoven, pieces by Louis Armstrong and Chuck Berry, as well as folk music from around the world. The record also contains an instruction on how to access the data on its back. However, let us not dwell on the past, but look at the future of the Voyager project. Where are the spacecraft now, and what awaits these solitary space wanderers? The Voyager's chief mission, exploration of furthermost planets in the solar system, was completed long ago. Now, the main objective of both probes is studying transitive areas between the Sun and interstellar plasma. The Voyagers travel at 17.07 km per second and 15.64 km per second, respectively. At the moment this video is posted, the distance between the Earth and Voyager 1 is approximately 21.7 billion kilometers, while Voyager 2 is 17.9 billion kilometers away from us. The spacecraft's missions differ by their trajectory. Voyager 1 flew only by Jupiter and Saturn, while Voyager 2 went further and flew by Uranus and Neptune as well. That is the reason why Voyager 2 is never going to catch up with its twin brother. In 2012, Voyager 1 left the heliosphere boundaries to cross into interstellar space. It follows a hyperbolic trajectory, so Voyager 1 is not going to return to the Solar System due to the gravitational force of the latter. Its twin overcame the heliopause only in November 2018. Leaving the heliosphere does not actually mean leaving the Solar System. To do this, one has to go as far as the Oort cloud, a hypothetical region of the Solar System and a place of birth of ice comets. Only there will the gravity force of our star become negligibly feeble. The Voyagers are powered by plutonium-238 radioisotope thermoelectric generators. After 42 years, the power of the probes went down to 55% and is now 249 watt as opposed to 470 watt at the time of launch. This does not allow full application of the probe's scientific equipment. Only 5 out of 10 devices are operating now: the cosmic ray system, the low-energy charged particle instrument, the magnetometer, the plasma wave subsystem and the plasma instrument. Now the Voyager mission members are struggling to maintain the equipment's operation. According to preliminary estimates, the minimal energy generation required for scientific studies will be sustained till 2025. This time is hoped to be sufficient to explore interstellar space, in particular the structure of the heliopause. In the future, the data may be used in planning missions to the stellar system closest to us, Alpha Centauri. By about 2030, the probes will switch into a radio beacon mode and will transmit the last signal to the Earth in 2036. Thus, the life expectancy of the Voyagers will reach about 59 years. One must admit, it is quite a period for a space trip. In about 300 years, Voyager 2 is going to reach the inner edge of the Oort cloud and will completely leave it only in 30,000 years. According to the data provided by the Hubble telescope, it will take Voyager 2 approximately 2,000 years to cross the gas cloud in which the Solar System floats. It will take the probe about 90,000 years to get into other interstellar clouds. The remains of the Voyagers are presumed to reach stars as well. In about 40,000 years, Voyager 1 is supposed to pass Gliese 445, a star in Camelopardalis, within a 1.6 light-years distance. Meanwhile, its twin will approach Ross 248, a star in Andromeda, at 1.7 light-years distance. In 296,000 years, Voyager 2 will fly by Sirius at a 4.3 light-years distance. Life-sustaining planets are unlikely to exist in the vicinity of either Ross 248 or Gliese 445. Both of them are red dwarfs, each of them hardly half the mass of the Sun. Ross 248 is notable for being a flare star, that is, one that spontaneously flares up. At about the time Voyager 2 approaches Ross 248 closest, the closest star to the Sun will for a short time be Ross 248, and not Proxima Centauri. The Voyagers are to remain eternal wanderers in the universe. They won't be able to leave the Milky Way and are destined to wander around our galaxy. They have lived through scores of failures on their journey, but in spite of that, they continue to operate, transmitting important scientific data to the Earth. With the initially planned 5-year lifespan, they're pushing their 4th decade of service. As far as I'm concerned, the Voyager project is the most successful idea in the history of space exploration. The data received during the mission have changed man's perception of the Solar System. It is hard to tell whether an extraterrestrial race will ever read the message on the golden-plated discs on the Voyagers. Since the Solar System is 15 times faster than the Voyagers at circling around the galaxy center, it is possible that our planet will recapture the remains of the probes in some hundreds of millions of years. Maybe the message aimed at aliens will eventually be a greeting from a distant past to the human race of the future. Man's life has changed significantly when we learned to use optical devices for research. 410 years has passed since the time when Galileo Galilei pointed a 3-power spyglass at the moon, and just 29 years since the launch of Hubble, the first space observatory. Today, the distance to the edge of the observable universe equals approximately 14 billion parsecs, and this may well be called just the beginning of our exploration. It is interplanetary space probes that are going to herald the next stage. The most famous ones, like the Voyagers on New Horizons, are known worldwide. But among spacecraft like these, there are veterans as well. One of them is the Cassini Interplanetary Orbiter, which started its mission back in 1997 and completed it quite recently. What did this spacecraft discover, and what did it get to observe in the 20 years of its historic mission? Originally, the Cassini project implied exploring Saturn and its satellites and delivering the Huygens lander to Titan. The project was made real by the efforts of several organizations, including NASA, ESA, the Italian Space Agency, and others. About 260 scientists from 17 countries were involved with the project. The Huygens lander was created by the European Space Agency, with the systems section produced by Lockheed Martin specialists. One of NASA's departments was in charge of the flight. The initial weight of the spacecraft was 5 tons 719 kilos. Its height was 6.7 meters and its width 4 meters. The 320-kilo probe, 336 kilo scientific instruments, and 3,310 kilos of fuel all added to the impressive weight of the spacecraft. Cassini was powered by radioisotope thermoelectric generators using radioactive plutonium-238 for fuel. Also, the spacecraft had 12 scientific instruments on board, among them a mass spectrometer, an ultraviolet radar, a magnetometer, and others. The spacecraft was launched on October 15, 1997 from Cape Canaveral. In order to gain the desired speed, the spacecraft was initially flown in the opposite direction from Saturn and passed Venus twice. Then, in August 1999, Cassini flew by the Earth at the speed of 69,000 km per hour. It used the opportunity to test its cameras and take a splendid picture of our satellite. After this, the biggest planet of the solar system was awaiting it, Jupiter, which was passed by the spacecraft on December 30, 2000. Cassini managed to take quite a number of pictures of this planet, as well as a few of its satellites, thus providing substantial amount of scientific data, including Jupiter's atmospheric circulation. As soon as on the 30th of June 2004, the spacecraft reached Saturn and achieved its final goal by becoming the planet's first artificial satellite. It was coasting at the orbital speed of 15 kilometers per second. The Huygens probe on board the Cassini spacecraft was supposed to take it from there. On the 25th of December 2004, Huygens detached itself to set out on its deliberate way to the surface of Titan even before Cassini entered into orbit around Saturn. On the 14th of January 2005, the probe penetrated the atmosphere of the mysterious satellite. It touched down on the hard surface 2.5 hours later. In the following 72 minutes, Cassini received signals from the probe on the Titan's surface and beamed back 350 images to the Earth. Thanks to the data received, it became known that there were not only rivers and lakes on Titan, but rounded hydrocarbon pebbles and methane clouds. Cassini undertook further exploration of the satellite. In the period of 13 years, it flew by Saturn's largest satellite over 100 times and stumbled upon a great number of discoveries. The most fascinating of them was that islands on Titan's lakes submerged and re-emerged. However, the precise mechanism of this phenomenon remains to be found out. During the time Cassini was operating, astronomers from the Earth discovered 7 new Saturn satellites thanks to the pictures transmitted from the spacecraft, with the very first discoveries made during the time Cassini was approaching Saturn. Saturn's new moons were dubbed Pallini, Polydeuces and Methone. While Cassini remained in Saturn's orbit, there were discovered satellites later named Daphnis, Anthe, Aegean, and a curious satellite S2009-S1, which hasn't been given a name yet. This satellite is the closest to its planet. Speaking about the most impressive discoveries made by Cassini, 2 fascinating phenomena may be singled out. These are aurorae in Saturn's atmosphere and an exciting hexagonal jet stream with a red hurricane inside. Soon after Cassini's discovery of this mysterious hexagon, another unaccountable property of the vortex was registered by astronomers. With passing years, the vortex changed its color. The area of this hurricane is 50 times that of the average hurricane on the Earth. The next objective for exploration was Saturn's rings. It should be noted that some of them, like the Anthe arc or the Pallini ring, were discovered by Cassini itself. A number of finer details were revealed by Cassini as it observed the rings. For example, how shepherd satellites like Daphnis kept close watch on the rings and how an ice belt built up on them. It was also thanks to the Cassini mission that it became known that there is a water ocean under the crust of Enceladus, just like under the crust of some of Jupiter's satellites. This ocean might have the correct chemistry for sustaining life. But unlike Europa or Ganymede, the ocean on Enceladus is possible for us to explore. Cassini flew through its geysers a number of times. The data received are soon going to be used for creating devices for a new mission to Saturn, Europa Clipper. In the 13 years Cassini spent on Saturn's orbit, it received 635 gigabytes of data and took almost 500,000 photos. Before the spacecraft was launched, only 18 of Saturn's satellites were known to scientists. In the 7 years Cassini was traveling to Saturn, 13 more satellites were spotted. And during the spacecraft's operation, 22 more satellites were discovered, 7 of which directly thanks to Cassini's pictures. Today we know 82 satellites of this planet, 20 of them were discovered quite recently. This makes Saturn the richest planet in satellites in the solar system. At the end of its mission, Cassini discovered yet another surprising phenomenon, a space between Saturn's rings. Just before the mission's grand finale, the spacecraft positioned itself between rings, and instead of expected dust vortices, it observed just an absolutely empty space. Cassini's fate was sealed in May 2017. Due to the lack of fuel, any further operation of the spacecraft in orbit was no longer possible. The mission's management considered 19 options of the probe's destiny. One of them involved steering it to orbit around the Sun or of one of Saturn's satellites. But in the end it was decided to let Cassini burn up in the gas giant's atmosphere. The decision was supposed to prevent the Saturn's satellite's possible biological contamination. On the 22nd of April 2017, Cassini performed a maneuver around Titan and found itself between Saturn and its closest ring. The spacecraft kept taking pictures till the very end. This is what its last photo beamed back to the Earth looked like. On entering the planet's atmosphere, the spacecraft pointed its aerial to the Earth and began transmitting data about the chemistry of Saturnian atmosphere. Soon after the connection with the orbiter was lost, it burned up in the dense strata of Saturnian atmosphere. Even though the Cassini mission wasn't as tremendous as missions to Mars, it proved extremely useful to contemporary astronomy. The spacecraft brought scientists up to speed with truly unique images on a monthly basis. Thanks to these, many aspiring astronomers built their careers using this database. The result of the mission indeed surpassed all expectations, because today we can realistically talk about discovering life on Saturnian satellites. Perhaps we will soon find out about these discoveries, and then it will be perfectly clear who to give credit for this. Voyager 2 would never have made any of its discoveries had it not been for something that happened in the 1960s that was to revolutionize our today's perception of celestial bodies. In 1964, when Gary Flandreau, then an intern at NASA's Jet Propulsion Laboratory, started drawing graphs of planets' future positions, he soon found that all the planets beyond the asteroid belt were going to align in a very narrow sector of the sky in the late 1970s. In our system, this phenomenon occurs once every 175 years, and this was a unique opportunity. By performing gravity boost maneuvers, a spacecraft would be able to whiz from one planet to another, thus exploring them all. It would also reduce the time of the flight, which would greatly boost chances of success. However, due to potentially high costs, this ambitious project had to be rejected. That's why NASA came up with something different. In 1977, a cheaper project was planned, namely Mariner Jupiter-Saturn 77. Even though the two probes were intended to explore exclusively Jupiter and Saturn, the scientists in charge of their development designed the probes in a way for them to be ready for a prolonged journey. The first probe's trajectory allowed it to additionally pass Titan, one of Saturn's moons with its own atmosphere. As for the second spacecraft, it was able to fly by Uranus and Neptune. Half a year before the planned launch, it was decided to change the project's name. Thus, the Voyagers made their appearance in the history of space discoveries. Running ahead, it should be mentioned that in their long history, the Voyagers have discovered a number of phenomena whose existence was to be confirmed only many years later. Jupiter's tumultuous atmosphere, Saturn's changeable rings, and Neptune's dark spot. All these discoveries were made possible thanks to the ambitious experiment NASA's scientists ventured to carry out. 9 years after its launch, Voyager 2 became the only spacecraft to ever reach Uranus. In order to boost up its connection with the Earth, a 64-meter DSN antenna and two 24-meter antennas were arrayed back on our planet. The spacecraft's cameras were supposed to be able to beam back several thousand pictures. Things we already knew about Uranus before the Voyager's approach, its rotation angle, 9 rings and 5 of its satellites, the information scrupulously gleaned for hundreds of years by the most prominent minds of our planet, comprised a tiny portion of the information that has been made available today thanks to that single swift flyby. On the 7th of June 1985, the first navigation pictures of Uranus' system were taken, but it was not until November the 6th that the camera moved on to taking more detailed images. It is quite extraordinary that the magnetometers kept silent in November, December, and even the first half of January. At the same time, the Earth radiation meter quietened down only after the orbit of Mars, while Jupiter's radio emissions persisted from the very day of the launch. Michael Kaiser from the Goddard Space Flight Center prophetically remarked, "It's either that we've encountered a planet without a magnetic field, or else it's so bizarre that we don't know what to look for." Thanks to the Voyager's investigations, it is now known that Uranus's magnetic field has some features due to its peculiar rotation. The peculiarity lies in the fact that the magnetic dipole does not coincide with the planet's rotation axis. It is in fact displaced by 1/3 of its radius relating to its center. Besides, the magnetic axis is tilted with respect to the rotation axis at an angle of 60 degrees. Uranus's magnetosphere doesn't look like a wide stripe, but is rather lopsided due to the strong tilt of the rotation axis to the magnetic axis. On the 27th of December 1985, Uranus's latitudinal zones were clearly visible in the transmitted images, dark brown at the poles and light at the equator. On the same day, thanks to the snapshots, Stephen Sinnett was able to confirm the discovery of Uranus's first unknown satellite, 1985 U1. It was traditionally dubbed after a character from a play by William Shakespeare, 15 Puck. In the following several days, Voyager 2 carried on taking pictures of the moons, among them already known Titania, Oberon, Ariel, Umbriel and Miranda. However, their number grew threefold thanks to the pictures. On the 16th of January 1986, the Voyager 2 project team announced the discovery of 6 more moons with the help of the photos. The largest objects, 1986 U1 and U2, were discovered in the photos examined on January the 3rd. U3 was discovered on January the 9th, and U4, U5 and U6 were registered on the 13th of January. The temporary designations of Uranus's satellites were substituted by these up-to-date names: 12 Portia, 11 Juliet, 9 Cressida, 13 Rosalind, 14 Belinda, and 10 Desdemona. In the images of January the 20th, some details of the relief on the surface of Oberon, Titania and Ariel were distinguishable, and 2 more satellites were discovered on that day, U7 and U8, 6 Cordelia and 7 Ophelia. On January the 22nd, Voyager 2 set off on its first flyby program V751. In addition to taking regular snapshots of the moons, it captured the patchwork of the Uranian rings and Umbriel in color. In one of the images taken on the following day, Bradford Smith found one more satellite, 1986 U9. It was later dubbed 8 Bianca. Miranda, or rather its peculiar terrain, was a discovery that amazed NASA's astrophysicists. It was possible to distinguish it thanks to the Voyager's pictures. The outer layer of Miranda's crust is covered with crevices, dales, cliffs and ravines, which together form a hybrid of geological features from different worlds. According to explorers' estimates, at least 10 types of terrain find themselves on a celestial body of a measly 500 kilometers in diameter. After that, it was time to discover Uranian rings. When Voyager 2 was passing through the planet's rings plane, a great multitude of dusty particles were observed 115,000 kilometers away from the planet's core and 60,000 kilometers away from the outer ring Epsilon. It looked like a diffuse nebula 4,000 kilometers thick. Thus, 2 new Uranian rings were discovered by Voyager 2. The first ring was located between the Delta and Epsilon ones and was given the temporary designation 1986 U1R. In direct sunlight, it looked very narrow, just about 1 or 2 kilometers, and faint, and only by using ultraviolet detectors were astronomers able to observe it. Later, Uranus's 10th ring was seen in the images. This picture shows all of them, from the bright Epsilon ring to the faint line of the 6th ring. The existence of the second ring discovered by Voyager 2, dubbed 1986 U2R, was confirmed only in 2004. It was located 39,500 kilometers away from the planet's core, and within 20 years it had migrated beyond, now finding itself within the distance of up to 41,350 kilometers away from the core. Before bidding farewell to Uranus and faring onward towards new horizons, Voyager 2 took its last snapshot of the planet. At the moment when this picture was taken, the probe was already 1 million kilometers away and was making for yet another mystery of the solar system, Neptune. This encounter would herald a major scientific breakthrough. At the same time, billions of kilometers away, thousands of people held their breath in anticipation of yet another step into the unknown. This was the famous Voyager 2 probe, which still remains the only apparatus to have flown by Neptune. Voyager 2 spent just a few months near the planet, but even in that short time span, it was able to get a great amount of valuable information. Neptune was the last big object to be seen by Voyager 2 before the probe entered the heliopore's boundaries and came into interstellar space. But what did the last shots from Neptune look like? Before you find out what it was, let's look at the probe's history. August the 20th, 1977. This is the day when Voyager 2 left the surface of the Earth. 41 years later, it was to go beyond the boundaries of the entire solar system. Initially, its mission implied only the exploration of Jupiter, Saturn, and their satellites. But the flight's trajectory presented the opportunity of flying by Uranus and Neptune as well. As soon as on July the 9th, 1979, Voyager 2 was 71,000 kilometers away from Jupiter. The probe also flew by its satellites Europa and Ganymede. The images received from the spacecraft gave grounds for putting forward the hypothesis of there being a liquid ocean under the crust of Europa. The observation of Ganymede showed that it was covered by a dirty ice crust. By the time 2 more years had elapsed, Voyager 2 was 101,000 kilometers away from Saturn. The probe flew by its satellites Tethys and Enceladus and transmitted detailed pictures of their surface. According to initial forecasts, that was supposed to be the end of its mission, but Voyager 2 continued on its course. January the 24th, 1986, the spacecraft approached Uranus and passed it at the distance of 81,000 kilometers. Voyager 2 sent a number of photos to the Earth. The planet's satellites, as well as its rings and surface, were to be seen in the pictures. It is thanks to them that 2 more Uranus's rings were discovered and the 9 already known ones were studied closer. 2 more years later, Voyager 2 found itself in the vicinity of the furthermost object of its mission and passed Neptune within 48,000 kilometers on August the 24th, 1989. It was able to take unique photographs of this giant and shoot Triton, its largest satellite. Active geysers were discovered on Triton, which came as a big surprise given the remote position and low temperature of this celestial body. Only 21 years after that did the probe cross the termination shock and entered the heliopause. 11 years on, and Voyager 2 passed through this area as well to come into interstellar space to stay. But what did the last planet seen by Voyager 2 look like? Many of you will certainly agree that Neptune rates as practically the most mysterious planet in the solar system. It is a body closest to Uranus in terms of its composition. It is perceived as a huge blue planet as a rule, and is even classified as an icy giant. Neptune's atmosphere is similar to that of Jupiter, and is mainly composed of hydrogen and helium. The planetary interior is for the most part made up of stone and ice. The color blue comes from methane in the outer layers of the atmosphere. Neptune's diameter earns it the 4th place among the other planets of the solar system, and it holds the 3rd place in terms of its mass. This planet is 17 times the size of the Earth. Neptune is also known for its dire climate. The strongest winds in the solar system blow in its atmosphere, and according to some estimates, their speed may reach 600 meters per second. A wind of this force would upend any object of average size landed on the planet's surface. The temperature on the surface of Neptune is close to minus 220 degrees Celsius. But if you were to find yourself there, the cold and fierce wind would not be the most trying ordeal. What is much scarier is that 1 year on Neptune would cost you 165 Earth years. Since the time Neptune was discovered in 1846, just over a year has passed on this planet. So, what could Voyager 2 see around that cheerless place? The first pictures taken by Voyager 2 as it was approaching Neptune were received on the 23rd of January 1989, when the probe was 310 million kilometers away from the planet. As the probe got closer, the images revealed formations in Neptune's atmosphere. These 3 images were received at a 90-minute interval. The photos allowed scientists to see atmospheric clouds, as well as notice a huge dark spot. The size of the spot was similar to the Great Red Spot on Jupiter. It should be noted that this area on Neptune was 10% darker than the atmosphere surrounding it. When Voyager 2 got closer still, it was able to see the planet in color. These photos were taken from the distance of 176 million kilometers. There was a 5-hour difference between them, during which time the planet had rotated 100 degrees. The probe's next objective was the closest satellites. On July 3, 1989, it was able to take a picture of Triton and capture both Triton and Neptune in one image. The probe kept getting closer and launched another active series of picture-taking 35 million kilometers away from Neptune to capture the nebulae for closer study. Apart from the Great Dark Spot, a few dozens of similar formations were observed. In this contrasting image, Voyager 2 managed to capture thin and bright clouds. This picture made it clear that they floated much higher than the Great Dark Spot. The next couple of photos was taken at a 17-hour interval, and it could be seen that the Great Dark Spot completed the almost full turn around the planet. The scientists realized that spots like these are able to move around Neptune at the speed of 100 meters per second. The Voyager's images also made it possible to gauge the wind force, which in some areas reached as much as 700 meters per second, which is practically the sound speed. The closest distance of the probe's approach to the cloud layer of the planet made it 4,900 kilometers. The images depict cirrus clouds casting their shadows on the layer of continuous clouds underneath. During its flight, Voyager 2 was able to take pictures of several satellites, for example Triton and Nereid. Having done that, the probe continued on its course and bid its last farewell to the views of this planet. The last image taken by Voyager 2 near Neptune does indeed look like a goodbye. The probe had entered a shadow at the time. That is why just part of the icy giant can be seen. That was the end of their short acquaintance, and Voyager 2 left those parts, never to return again. Voyager 2 still remains the only spacecraft to have reached Uranus and Neptune. Its successful mission was outstripped only by that of the New Horizons probe, which reached Pluto in July 2015. Voyager 2, however, will always remain a legend of space exploration. In about 300 years, it will reach the Oort cloud and will sail beyond it only in 30,000 years. It is highly likely that by that time, more than one exploration mission to Neptune will have been launched, but the achievements of Voyager 2 can truly be called a worthy beginning of this story. Things concealed by the stars nearest to us will attract scientists, amateur astronomers, and science fiction writers from the Earth for decades, if not centuries, to come. Ways to gauge the magnitude of the universe differ from each other, but it is generally true to assume that the solar system stretches in all directions as far as 1 light-year from the Sun. Beyond that frontier, just a few light-years away from the Earth, there are the stars closest to us. The closest out of approximately 200 billion of those in the Milky Way. Every star is an exploding hydrogen ball resembling our Sun, and each of them is unique. The Sun, the basis of our system, is the closest star to the Earth. Unlike other stars, it is clearly visible in broad daylight. As for other celestial bodies in the infinite space, they can be seen in the night time. However, stars differ in terms of their real brightness. Scientists have defined the closest celestial bodies within the radius of 16 light-years. 57 stellar systems have been pinpointed, but only 7 of them can be seen in the sky without any optical assistance. These are Sirius, Alpha Centauri, Epsilon Eridani, Procyon, Epsilon Indi, Tau Ceti, and 61 Cygni. Some of them are not just solitary bodies, but binary or triple stars, so the overall number of these celestial bodies reaches 64. 13 brown dwarf stars are also included in the list. They are considerably lighter than the other bodies. Proxima Centauri is our closest neighbor of all, which is 500 times less bright than the Sun. It is one of those secretive ones that are invisible to the naked eye. That could be the reason why this object was discovered only in 1915. It is the third and actually smallest stellar component in the Alpha Centauri system. In contrast to the Sun, which finds its way around the galaxy on its own, Proxima Centauri is locked in its orbit, stretching for 1 million years around the 2 other stars. This couple, known as Alpha Centauri A and B, is perceived as one star by the observer on the Earth who isn't employing telescopes or binoculars. Besides, it is one of the brightest systems in the sky. Both stars in the system resemble the Sun much more than Proxima itself. Proxima's color is completely different from that of the Sun because this star is much colder, 2700 degrees Celsius, as opposed to 5500 degrees on the Sun. Alpha Centauri A is 1.5 times brighter than the Sun, and their surface temperature is almost identical. In contrast, Alpha Centauri B is 2 times weaker than the Sun and about 500 degrees colder. Interestingly, in August 2016, scientists announced the discovery of a planet the size of the Earth going around Proxima Centauri. This new object, known as Proxima B, is about 1.3 Earth masses, which according to scientists may mean that this exoplanet is a rocky world. Its location in relation to the star makes it habitable. It is the correct distance away from the star for water to accumulate on its surface. Proxima B is 7.5 million kilometers away from its star, and it is likely that it's blocked. That is, it faces the star by one and the same side, just like the Moon, which shows the Earth only one of its parts. By the same token, it's worth mentioning that according to scientific estimates, it would take a spaceship from the Earth about 70,000 years to reach Proxima Centauri. However, with the data received with modern telescopes, it is still not clear whether Proxima B may be habitable. Speaking about the next of our closest stars, it's another red dwarf, Barnard's star, which unfortunately isn't clearly visible either. However, it is the 4th nearest star after Proxima Centauri and before Laaland, and is located in a completely different direction, namely in the constellation of Ophiuchus, and 1.7 light-years further than Proxima. This little star is considerably smaller than the Sun, being only 0.17 of its mass and diameter. In fact, it was discovered comparatively recently, even though it's the fastest moving star in the sky, crossing the distance equal to the diameter of the full moon in 180 years. The flying Barnard is notable for its rapidity of movement. It moves towards the Sun, and eventually it is going to be closer to us than Proxima Centauri. The color of the star is the direct indicator of the temperature on its surface, just like a metal rod, which when heated first turns red, then orange, after that yellow, then white, and finally blue. For decades, Californian scientists have been making great efforts to discover planets in the vicinity of Barnard's star, but so far there are no data as to their existence. Here is another cluster of brown dwarfs, the constellation of Vela or Sails, located in the southern hemisphere. This constellation is our second closest star after the Sun. Interestingly, it is difficult to observe from the territory of Eurasia. You can see only part of it in the southern regions of Russia, and the more to the south you are, the higher the chances to observe the constellation. By the way, the best conditions for observing at least some parts of it are in February. Speaking about the stars of this constellation, the brightest one should be mentioned first, Gamma Velorum. It is also nicknamed the spectral gem of southern skies for its rays, which boast incredibly bright emission lines as opposed to dark absorption lines, which are generally more common. That is the reason for the rather exotic spectrum of the Gamma star. 800 light-years away from us, this star is the second largest in the constellation and is made up of at least 6 components. Also, Gamma 2 Velorum is also generally considered rather bright. It includes several stars, one of which belongs to the Wolf-Rayet set of stars. But these aren't all the massive bodies in the Vela constellation. For example, the mass of the Lumen 16 system is 30 Jupiter masses, with its brightness flaring up and fading from time to time. It is almost 7 light-years away from us. At the same time, the mass of another component of Lumen 16 equals 50 Jupiter masses. This binary stellar system was discovered comparatively recently, in 2013, while no celestial bodies or exoplanets have been discovered in its vicinity. Most people perceive it as one single star. However, in reality, Sirius is a binary stellar system consisting of 2 space objects, Sirius A and Sirius B. Both stars orbit around their common gravity center at a distance of approximately 20 astronomical units. Just to compare, this is only 1 astronomical unit more than the distance from Uranus to the Sun. Their orbital period around the gravity center is 50 years. Sirius A is the main component. It is a visible star of spectral type A1, which has long been perceived as the only star in the system. It is about 2 sun masses, with the radius exceeding that of the Sun by 71%. Due to its close proximity, Sirius A is one of the easiest objects for amateur astronomers. The star is 8.6 light-years away from our system, and its brightness is 25 times as intense as that of the Sun. In addition to its superiority over our main star in terms of its dimensions and mass, this celestial object also beats it in the temperature level, which may reach 9,940 kelvins on its surface, as opposed to only 5,778 kelvins on the Sun. The most exciting peculiarity of the object is a high level of iron in its atmosphere, which is 316% as abundant as on the Sun. Also, the spectrum shows that other elements heavier than helium are to be found. The star is likely to have been enriched in metallic elements tens of millions of years ago by a neighboring object. Speaking about its future evolution, Sirius A will probably continue to exist as it is for another 600 million years or so, after which it will turn into a red giant and then a white dwarf. Even though only several thousand white dwarfs are known to science today, this kind of final state is typical of stars relatively similar to our Sun in terms of dimensions and mass. These objects are hard to discover, which has to do with their low luminosity and small diameter. However, according to scientists, their overall number in our galaxy is estimated to reach 10 billion. That is about 5% of all stars in the Milky Way. The second component of the Sirius stellar system is exactly one of such objects, which is the first white dwarf to have been discovered. As far back as in 1844, the famous German astronomer Friedrich Bessel noticed that the trajectory of Sirius A from time to time deviates from its linear motion. Bessel accounted for this behavior by suggesting the existence of a hidden mass orbiting together with the star around a common center. This hypothesis caused a lot of skepticism, for if it held good, the mass of the latent satellite was supposed to equal that of our Sun. Nevertheless, 18 years later, in January 1862, Bessel's assumptions proved to be true. While testing a new 46-centimeter refractor, the American astronomer Alvin Graham Clark sighted a tiny star near Sirius. Its orbital movement corresponded to Friedrich Bessel's calculations. The star was dubbed Sirius B. This object is the heaviest white dwarf of all known to science, and has approximately the mass of the Sun. But even in spite of this indicator, not typical of this celestial object's variety, its volume accounts for less than 1/millionth of that of the Sun, and its dimensions almost equal those of the Earth. Before becoming a white dwarf, the star is likely to have completed the two basic stages of star evolution: the main sequence stage and then the red giant stage. Scientists believe that the process of turning into a white dwarf took place approximately 120 million years ago, and the star's mass used to be 5 times that of the Sun. At this moment, Sirius B is barely luminous, with its luminosity being 0.026 that of the Sun, and with an exceptionally high temperature of 25,200 kelvins on its surface. As Sirius B has no internal heat source, it will gradually cool off, and will eventually become a hypothetical black dwarf in over 2 billion years' time. However, this kind of object hasn't been sighted by scientists yet. Unlike its younger neighbor, this star isn't easily observable in our sky, which is the reason why Sirius B has long been inadvertently ignored by science. Only on October 15, 2003 did scientists receive a clearer image of the object with the help of the Hubble telescope. Both stars are visible in this picture: Sirius A, the brighter one, and Sirius B, the tiny one. The object is located in the well-known constellation Canis Major in the southern hemisphere of the sky, but it is visible to the naked eye in the northern hemisphere as well. Due to its perfect visibility, Sirius has been studied by mankind for a great number of years, getting shrouded by an increasing number of legends. As far back as in ancient Egypt, the object was referred to as the Nile star and was associated with the name of the goddess Sobdet, as its morning rise heralded the river flooding during the summer solstice. Sirius is mentioned in the works of the Roman scientists Seneca and Ptolemy, who described the star as scarlet. The object also holds a place in the history of Mesopotamian and Chinese astronomy, and is also characteristically referred to as a bright red star. Due to such conflicting descriptions, Sirius became notorious for being the object of manifold pseudo-scientific theories. The temporary reddening of the star can be explained by the influence of interstellar dust, which for a while came between Sirius and the Earth, with the effect of giving the radiance a reddish hue. Another explanation could lie in the possibility of there being a third component in the system, whose orbital period equals about 2,000 years. When in close proximity to Sirius A, this hypothetical celestial object could cause the star to flush red. Nonetheless, to date, nothing even faintly resembling this kind of object has been discovered. In April 2018, NASA launched the Transiting Exoplanets Survey satellite, TESS, with the aim of finding exoplanets orbiting bright stars. Due to the fact that Sirius is a young star, it is rather unlikely that any planets will be discovered in its environs, but the satellite will collect data that will facilitate its investigation in more detail. Even if there is at least one big planet in this system, life cannot be sustained there, as too little time has passed since the formation of the star itself. Apart from that, any planets within the habitable zone must have been burned out when Sirius B was in its red dwarf stage, and as a result there is as good as no chance of discovering any life forms in this system. Sirius is likely to be a relatively young system according to modern estimates as well, its age gauged as being between 200 to 300 million years. Procyon is the closest star to Sirius, being 5.2 light-years away. The Sun holds the 6th place on this list, although this may well change in the future. The point is that Sirius approaches our system at the speed of 7.6 kilometers per second, which is why its brightness visible to us is going to gradually intensify. Sirius will remain the brightest star in our sky for thousands of years to come, after which the process is supposed to be reversed, with the star growing ever dimmer to the observer on our Earth. In our modern age, some may think astronomy to be a young science, as most discoveries are being made with the use of state-of-the-art equipment. However, the movements of celestial bodies have been studied throughout the entire history of mankind, and the star Sirius is a perfect confirmation of this. The statement that there are boundaries to the universe is considered per se one of those great ideas which are able to dramatically change our world perception. Something similar took place back in 1543 when Nicholas Copernicus proved that the Earth wasn't located in the center of the cosmos. The following breakthrough took place in the 20th century when Edwin Hubble showed to the world that galaxies moved away from each other. This prompted the idea that the universe hasn't existed eternally and was formed as a result of a certain event, the Big Bang. Today we are certain that the dimensions of the world we live in are much larger than we are capable of imagining. The search for the answer to the question about its boundaries is going to lead to yet another scientific breakthrough. At the moment, scientists are able to talk only of the boundaries within which the objects are visible. This area is also called the observable universe. That is its part which is the absolute past in relation to the observer. The cosmic horizon is the boundary of the observable universe. The objects on the horizon become infinitely redshifted, that is, they constantly move further away. The number of galaxies within the observable universe is estimated at upwards of 500 billion, with this number increasing on a regular basis as the research equipment becomes more advanced. But how big is the observable area of the universe today? The distance to the remotest observable object equals approximately 14 billion parsecs in all directions. Thus, the observable universe is a sphere with a diameter of about 93 billion light-years and with the center inside the solar system. That is, it is centered on the observer. The area equals 350 quinvigintillion cubic meters. It should be mentioned that the light emitted by the furthermost observable objects has been traveling for 13.8 billion light-years before reaching us. However, the distance to those objects has significantly grown due to the never-ceasing expansion of the universe. This process is the result of there being matter and energy in space, filling space-time. While there is matter in space, there is gravitational force. Therefore, the universe either shrinks, affected by gravity, or expands, affected by dark energy. It is also worth noting that there isn't a single center for the universe's expansion, just like there isn't a space for the universe to expand into beyond its boundaries. This process takes place with the matter in space at any point, everywhere and at all times. We do not physically perceive this, as the force holding our atoms and molecules together does not allow us to burst under the influence of the space expansion. This may be compared to a baking loaf of bread, with the raisins for galaxies and similar formations and the dough for the space matter. According to estimates, the distance to the furthermost observable objects today equals approximately 14 gigaparsecs, or 46 billion light-years. The furthermost stellar system with respect to the Earth is a galaxy dubbed GNZ11. Its light has been traveling to us for about 13.4 billion years, meaning that this object was formed less than 400 million years after the Big Bang. However, due to the constant expansion of the universe, today's distance to GNZ11 is approximately 32 billion light-years. One may argue that the speed with which it recedes exceeds the speed of light, but it does not clash with the special theory of relativity, as it isn't the matter that is receding, but the space between the two objects is growing larger. This object is supposedly one of the very first galaxies and is likely to be the closest stellar cluster to the edge of the observable universe. If man were able to freely travel from one world to another, it is in that galaxy that we might find out about the genesis of our world in more detail. What we call the meta-galaxy is likely to have started to expand immediately on its birth. In theory, the boundaries of the meta-galaxy may well reach the cosmic singularity. That is, it may show us what the world had been like before the Big Bang, but in practice it is relic radiation that is the limit to the observable. It is this radiation that is emitted by the furthermost object in the universe to have been observed in contemporary science. This radiation poses something like a barrier for our vision. It came about approximately 380,000 years after the Big Bang. That is, at the time when the universe cooled off sufficiently for atoms to emerge. In plain English, it is similar to an image of space in its childhood, where it is depicted before the formation of the first stars. It is likely that the universe stretches infinitely beyond this barrier, and it is there that its hypothetical boundaries are to be found. The objects beyond this barrier are referred to in a number of ways: multiverse objects, parallel universe objects, to name but two. Science today is incapable of defining these bodies with any detail. However, assuming that the universe carries on expanding, we may conclude that the objects we're able to observe now are sooner or later going to disappear from our field of vision. If the accelerating expansion of the universe continues indefinitely, the galaxies beyond our supercluster are sooner or later going to recede beyond the horizon as a result, thus becoming invisible to us. Any form of communication beyond the boundaries of the observable universe will be rendered impossible, and any contact between the objects will be lost. The Earth, the Solar System, the Milky Way and our supercluster will be mutually observable, whereas the rest of the universe will recede in the distance. There may be hypothetical worlds beyond the regions observable to us. They originate as a result of phase transitions of physical vacuum. Alternatively, there may be objects forming out of irregularities of relic radiation located closest to the particle horizon. The question of multiverse objects remains a bone of contention among scientists, prompting an overwhelming number of pseudo-scientific guesses. Be it as it may, most researchers see eye to eye as to the infinity of our universe, although they interpret it in different ways. Some of them claim our world to be multidimensional, which makes our three-dimensional universe merely one of its layers. Others are inclined to believe in the theory of a multi-universe, with us as a minuscule fraction of an infinite multitude, whereas there may be a portal to other worlds beyond the observable area of the universe. Some space theories involve the existence of the so-called event horizon. According to this concept, we're never going to be able to look beyond the event horizon, because the speed at which photons travel away from us will be higher than the speed with which the observable universe expands. According to this theory, all the galaxies surrounding us are bound to recede beyond the event horizon. It will look like time stopped in them. We will observe them infinitely receding beyond the observable boundaries, but never quite disappearing from view. Be it as it may, contemporary science cannot provide a definite answer to this question, although the situation may change overnight once we have developed more advanced observation equipment. The universe might turn out to be a sort of sphere, and traveling over it might remind one of traveling on the spherical surface of our Earth. Considering the scale it reaches, however, this prospect appears impossible. In order to reach the edge of the observable universe, it would take man 46 billion years, even if we travel at the speed of light. By the time we reached this designated point, it would have moved the same distance away, and a similar journey would have to be embarked upon. It is likely that there aren't any large objects beyond the observable universe, and on peering there, we would see just a homogeneous cloud of helium, hydrogen, and a few other elements. However, we might probably never be able to discover the origins of our world, and might forever remain in the position of someone chasing the horizon. What we have just covered is only a tiny part of the vast expanses of space. It may take humans more than 1 millennium to explore the rest of it. However, with the rapidity of the pace at which science strides forward, it is safe to say that every scientific breakthrough will exponentially facilitate our progress. And who knows, sooner or later we might get to the point when the universe will be explored with the same precision as the surface of our own planet.